Alright, so for this video we're going to go over variables, get a little refresher, and then kind of put some methods to madness here. So starting off, I've got some pre-code written here for this video. Notice I include an extra library called math.h at the beginning. That's just to use the power function that's located in that library, so I can show you some values here. So just as a refresher, there are different types of variables. There's a char, int, float, and double. Each of these can hold or represent a certain amount of values. So for a char has 8 bits in the memory when it gets declared. An int and float get 32 bits, and a double gets 64 bits. So what does that mean? That just means the more bits you have, the more values you can represent. So on this line, or these lines here, I'm going to print out how many bits each of these types have. I'm going to show that to you now. Okay. So for the char, you get 1 byte, which is, with a little calculation here as I show you, 8 bits per byte. So a char gets 8 bits. An int and a float have 32 bits each. And a double, as you can see, has 64 bits. So what does that mean? A char can hold 256 unique values with just 8 bits. Bumping up to 32 bits for int and float, it can represent 4 billion. That's kind of the 32-bit operating system. Those are kind of restricted to 4 gigs of memory. This is why. And for 64 bits, you can see is a really gigantic number. So float and double act the same way, as you will see later, but double can represent a lot more values. Okay, so moving on, I'm going to talk about chars here. So with a char, it can represent an actual character or a number. And since it's only 8 bits, the actual numbers that it can represent are 256 different numbers or even characters. There's an ASCII table out there that will represent a value, usually 0 to 127 is the pretty standard one. So 0 gets a certain character, 1 gets a certain character, 95 gets a certain character. So let's just do a couple of examples here. So with the placeholder, if you want to print out the actual character, you're going to use %C. But if you want to print out the decimal value, you're going to use %D. So for a quick example, I'm going to declare a variable. Sorry, I'll just call it var1. And I'll give it the character A, lowercase a. So I'm going to print that out. So I'm going to hit printf, give it the standard template here. And you should follow along as well. So first, I want to print out the character. So I'm going to use %C. Has a decimal value of, and then I'm going to use %D. Give it a new line. And now we need to put in the variable var1 for each of the placeholders. So I'm going to run that. Actually, I'm going to comment out this code first. I think I can do a block with a Control E and then C. That'll block out all of that. Okay. Alright, so A has a decimal value of 97. So if we look up the ASCII table, which we can do right here, ASCII, ASCII table, and I don't have internet, so great. Okay, so I should have internet now. Okay, so I'm just going to pick the first image, view image. A has a decimal value of 97. So in the red, we're going to look for the character A, the lowercase a. Here it is, and then if we go under the decimal column, it's 97. So let's jump back to our code. We can declare and define a char variable by giving it the value first. So let's just give it 97. And of course, I'm going to replace the variables here. So when it goes to print out var2 for this first one, var2 is 97, so it should print out the character A. And then for its integer representation for %D, should print out 97. And of course it does. So let's try something different. let's add plus 5 to this. So let's see, A is 97, B, C, D, E, F. It might be E. Let's just give it a try. So it's F. All right. So 97 plus 5 is 102. And then if we go to the ASCII chart, sure enough, there it is. Whoops. Lowercase f. So you can do some interesting things with the char variable and adjust it accordingly. But if you want to print out the character value itself, the actual character, you use %C, but if you want to print out the numerical value, it's %D. So just for giggles here, let's do a third one and give it the value, since this is signed, so by default everything is signed, so I can give it a -1 value here. And we'll try that. So giving a -1, I don't see anything here, but it knows it is -1. So the representative character is not found. So let's say we want to use an unsigned char, meaning there are no negative values. Let's try giving it -1 again. What I'm going to do is I'm going to comment out this line here. So I'm going to try and print out var3 -1. Same deal, but notice, look, it went to 255, not 256. 256, the char character represents 256 different values, but it starts from 0, so 0 counts as one of those values. So it doesn't go from 1 to 256, it goes from 0 to 255. So let's try and just make it 256 here. Try and force it to be above its maximum. And look, it looped back around. So it went 255 or 254, 255, and then if you try to go to 256, if you try to add 1 to 255, it's going to actually loop back around to 0. And it does that for all the variable types. Okay. All right, so moving on, we're familiar with ints. So now for floats. All right, for floats you need numbers that are fractional. They can be represented with a decimal. So like 2.0, 75,555.27, 0.000025, etc. Stuff like that. And then when we go to use the placeholder, we want to use %f. And then with %f, we can actually control what the precision is shown or printed to the screen by putting a period and then how many we want to show after that decimal. All right, so I'm going to show you some examples for floats. Let's create another variable. We'll call it, I don't know, float var. Not being very creative today. Let's give it a value of 159. Let's see, 3.14159. It's pi. Okay. So when we go to print it out, we're going to use the %f placeholder. So we're going to do printf %f is float var1, something like that. And then give it float var1 at the end for that placeholder. And give it a go, and sure enough, it prints it out. But notice it gave me an extra 0 there. It's going to print out to 6 places. So if we want to control that, we simply just give it how many places we want. So let's give this a try. Let's give it 1, 2, 3 places, and let's see if it will round for us. So I'm going to give it 3. We would expect 3.14, maybe just 1, and maybe 2. So let's give it a try. Okay, great, I got 2, so it actually rounded it for me. Let's try that one more time. On the same line, I'm going to, after the new line in the string, I'm going to try, how many places is this? 1, 2, 3, 4 places. So hopefully it rounds to 6. So I'll do 0.4 with an f is float var1. And since I have 2 placeholders, I need 2 variables after the string here. But it's the same variable. Okay, great. Yeah, it rounded for me. Fantastic. So let's do a little bit, or some more examples here that could be a little tricky. Alright, so we're going to just try and print out two numbers that don't divide evenly without using a variable. So divide 1 and 4, or 1, I should say 1 divided by 4, just using printf. So with that, let's do printf %d divided by %d is equal to some number %f. Or %f, we know it's going to be a decimal. We know it's going to be 0.25, right? So let's just give it a try and see what it does. Give it a new line, comment this line out so it's nice output. And the first placeholder will be 1, the second will be 4, and the final will be 1 divided by 4. Okay, I'm going to give that a try. So 1 printed out correctly, 4 printed out correctly, but it gave me 0. That doesn't make sense, right? Well, if you're doing it inside of printf, or if you're going to define a variable this way, the compiler that actually compiles your written code so that it can run it needs to know that this is a float that you're trying to calculate. So what you can do is take this 1 and put 0.0. Give it the decimal, like so. Now that should recognize that it's a floating point value, and it'll print out, hopefully, the correct answer. And sure enough, it does. So if we want to just control the precision, so it only shows the 2 places, give it the 0.2, and sure enough, there it is. Alright, so we're going to just make 2 variables, a and b, give it 2 different values. 3 divided by 3 and b is equal to 2, and then we're going to take these 2 values and divide them. So I'm going to give it %f like we've been doing it, give it the appropriate variables for each placeholder, and then the final expression. So I'm going to run it, and it gives us 0.0. So that's an issue, right? Well, what's happening is truncation, but since we're giving it a float and it doesn't recognize the actual answer as an int, as a float, it's getting confused. So let's just switch it back to %d. We're dividing ints, so we expect an int out. So 3 divided by 2, if it's using %d, will give you a 1. So what happened there? Well, it's getting truncated. Truncation. So the answer is 1.5, but what is actually saved is just the 1. Everything after the decimal gets chopped off. So let's try this again. Let's go for a bigger number, 9, 4. So the answer should be 2.5 when we go to run it. There it is, 2. So be very careful when you're doing division, because you might need a float even though your first 2 numbers are an integer. Okay, so let's try giving actual float variables here. So we'll declare it with float, c and d, giving c 9 and d 4. Let's use printf. %f divided by %f equals %f. This is all because it's floating type, right? So each placeholder needs a representative value. In this case, it'll be c for the first placeholder, d for the second, and then c divided by d. Give that a try. So notice it didn't need me to put the decimals when we go to define a floating type variable. It already knows it's a floating type. It's when you're just doing printf by itself and you're not giving it a variable, it has to deduce what you're trying to do. So you have to be very explicit when just giving an actual value in the printf, but when you're giving it a variable type or a variable, it'll know its type, especially using the correct placeholder. So there you go. And then as before, you can use the precision printing there, and just to show what you want to show. And doubles are pretty much the same thing as floats, except remember, instead of 32 bits of, 2 to the 32 different bits of different values, it has 2 to the 64. So it acts the same way, gets printed the same way using %f. Just to show you. Give it a placeholder. Give it the value for that placeholder, which is f. Give it a run. There it is. All right, so that was pretty much it on the different types of variables. I'd like you guys to go back into your first homework and fix it such that instead of using ints, you're going to use floats or doubles, either one. That way, when you go to do your division, it shows the correct answer. Because, right, some of the division doesn't show correctly, especially when the two ints don't divide evenly. So you need to go in and flip your %d's to %f's and redeclare your variables as a double or a float. And I'll have the details on that on Canvas.